In 5, 4, 3. Hey kids, it's time for a new chapter, and this is chapter 10-1 with the live studio audience.
Yeah.
All right. Have a quiet audience today. Kind of a sparse crowd today. Okay. Now 10-1. All right. Let's start off with a Latin phrase. And this Latin phrase is cogito ergo sum. As you can see it on your sheet. All right. Now, if you have not had Latin, all right, let's discuss what this means. All right. We'd like to say hi to Bailey Bogle, who's watching this at home, by the way, who's sick today. Okay. The future generations. Oops, I mean Stephanie Bogle. Yes, that's right. Okay. Welcome to the party, Bailey. And okay. Now, perhaps you know what ergo means because we actually use that in English. Ergo means
Therefore.
therefore. All right. Perhaps you've used that before in a sentence, or heard someone use it before in a sentence. Okay, ergo, therefore, thus. All right, so that's therefore. Now, cogito looks a lot like a word that we do have in English, actually. Cognitive, cognition, yeah. What is cognition? What is that? Okay. Yeah, it has something to do with thinking. Cogito, I think. Therefore, I am. Sum is I am. All right. So, you don't recognize it in Latin, but now that you see it in English, you recognize the very famous phrase, I think, therefore I am. Therefore I must exist. All right? And that is a phrase coined by a philosopher, of course, who is also a mathematician. And this mathematician is surprisingly not in the top 100. He did some important stuff. Not in the top 100, however, I bet almost everybody has heard of him before. You already know who I'll tell you. The kids are so clever. Rene Descartes, otherwise known as Descartes. French, that would be Descartes, of course, yes, Descartes. All right? And now there are a lot of characters in the top 100 that you have never heard of because you won't even hear about them until maybe college math or maybe never. Then there's this guy who's not even in the top 100, but everybody talks about him like in Algebra 1, maybe Algebra 2 somewhere. Okay? Descartes came up with two major things that we use now. The first one is he was actually the person who came up with the x and y axes. How about that? That's pretty important, right? Okay? Otherwise known as the blank plane. Cartesian, very nice. Wait a minute. Before I spell out Cartesian, what do we have right there? Ah, named after Descartes. I see now. Cartesian. Right? The coordinate plane, right? And he came up with that in 16 something, I think it was 37. About. And 1637 says, hey, let's just graph things with x's being right and left, y's being up and down, and then it opened up the whole world of graphing. Right there. Pretty recent development in world history, actually. Okay? All right. Now he came up with that. He also came up with something called the rational root theorem, which we will learn today. And it was a, perhaps you do. Okay? Very clever idea, this rational root theorem. Very nice, all right? Let's check it out. Okay, so let's start with something that is nice and facty for us. And we are going to examine where this rational root theorem comes from. Okay, so let's start with x plus 7 times 3x minus 2 equals 0. And we're going to try to find out where it equals 0. Okay, what's one obvious solution here? How about -7? Obvious solution, right? Okay. So where it says x equals there, let's put down x equals -7. And technically -7 is -7 over what? Over 1. Okay? So we know that. Now, the other answer, the other solution, would be what? 2/3. You add the 2 over, divide by 3, you get 2/3. Okay? This one we subtracted the 7 over, and then technically you can divide by the coefficient of 1, essentially. Now, notice what's right down here. See the 1 and the 3? Mm-hmm. Where did the 1 and the 3 come from? Those are actually the ones. Coefficients right here. That's a 1. So these are the coefficients. Okay? And then what about the -7 and the 2? Where do the top numbers come from? That would be these numbers, just opposite. Right? Okay? So just the numbers, but maybe we'll note opposite. So they always stay together. Those numbers always stay on top. The coefficients always stay on the bottom. And you'll see as we go throughout this problem that these two numbers will always be buddies, and the 1 and the 3 will always be buddies as well. Okay? Now, next step. let's go to FOIL. Oh, I tell you what, little vocabulary here. If you were finding where a function equals 0, there are several things we call these things. What are they called?
Okay, let's say one of them. One.
Roots, yeah. Roots would mean what are the zero? Yes, very good. Zeros. Okay, anybody ever heard of roots or zeros? Right? Where is it neutral? Where is it equal to 0? And the last one is graphical. Speaking about the Cartesian plane, this 0, it is. This 0 got plugged in for what, by the way? Wouldn't it normally be y equals? And the y became 0. If you change the y into 0, you were actually finding the what? The x-intercepts, right? And so roots, zeros, it's just the same as where does it cross the x-axis down. That's what we're finding here, okay? All right, so FOIL, all right? Let's do this first. So if you were to FOIL this out, what coefficients would you multiply first to get to here?
3 and 1.
Okay, 1 times 3. Like we said, they always stay together. They're always buddies. And then it would be x what? By FOIL, x squared. 2 on there. All right, I already put down the minus for you and the plus. Outer inner. So minus 2x plus 21x plus, then we have parentheses at the end. Okay, wouldn't that be the plus 7 times the negative 2 buddies staying together again? Right there. Okay, and you'll notice these right here are the coefficients, and these right here are the numbers.
So it's not opposite?
Okay, although, well, we're foiling from this, so those are actually the same. It's only the roots that are the opposite. Okay, now in a second it won't matter because we're going to do a little formula that has a plus or minus in it, and it won't really matter which way you go. You'll find out what it is. Okay, so they're staying together. Now, last thing, we'll throw in the college symbol implies right here, because you never want to write something equals something else equals and then keep saying it equals. So what you want to do is you want to say something equals something implies that, and then you go to the next step. And this is going to make, of course, what right here? 3x squared plus 19x. And then let's keep it a plus. 7 times negative 2 is negative 14 equals 0. Okay? So what's going to happen is I'm going to give you this trinomial right here. You're going to have to go backwards and go to there. Okay? Now, of course, it's pretty easy to factor, but I'm going to show you a trick. All right? Okay. Now, notice that this right here again came from these two numbers. This right here came from these two numbers. Okay? All right. So here is the rational root theorem right here, which I'll abbreviate as the RRT. The rational root theorem states that all possible roots of any polynomial has to be in the puzzle or the form plus or minus, and then on the top we'll have all the factors, or I won't say all, we'll say factors. Factors of the last number, or the last coefficient, over all the factors of the first coefficient. We're going to try for this one. Now this should work. Okay. On top, the negative 7 and the 2, that's part of the roots. Aren't negative 7 and 2 both numbers that go into negative 14 evenly? Okay. And on the bottom we had 1 and 3. Aren't 1 and 3 numbers that go into 3 evenly? Right? So by FOIL they all stay together. Okay? So let's try this. Plus or minus. And let's say we don't know where this came from right now. Okay? How would you start this problem? What you would do is you would look at the last coefficient, or the very last number, which is negative 14. You put the plus or minus, so it can go either way. And then you just focus on the 14. Don't worry about the minus, just the 14. What are the factors of the number 14? What's the smallest factor? 1. We have 1. We've got 2. 3 doesn't go in. Right? Wait a second. What's the
Square root of 14.
The square root of 14 is about what? Square root of 14 is about 3 point something. Okay. Sieve of Eratosthenes. Once you get past 3 point something, you're done with the halfway point. And 3 doesn't go in, right? And so everything left over is just a mirror image. The reason that 2 goes into 14 is because 7 does. The reason that 1 goes in is because 14 does. And it's not the midway point, it's not the halfway point, it's the square root point, isn't it? Right? That's the cutoff. All right. Now this is easy enough where you don't have to use the sigma cosines, but for bigger numbers, it definitely helps. All right. Now over, and the first coefficient was 3, and the factors of 3 would be what?
1,
1 and 3. Okay. Now, like we said, what created the 3 and what created the negative 14? The top of the roots created the negative 14. The bottom of your roots created the 3. So in this puzzle over here, the roots will always be hidden, guaranteed. It narrows it down from infinite possibilities to just a handful. Can you see negative 7 over 1 in the puzzle? Negative 7 over 1. It's in there. Can you see positive 2/3 in the puzzle? Positive 2 over 3. And then we have a lot of extra stuff that we'll have to weed out. But you can narrow it down to just a few possibilities here. And once you get to that in the rational root theorem, you can say, okay, I have a hint now as to what the roots are. Okay? Now, you can take this and factor it pretty easily, but we're going to have some awful equations that you cannot factor, that you can type into a calculator. They won't do it either, they won't do it accurately, but you can do this right here. Okay? Shortcut. All right, so let's go to example A, which is one of those functions that you would definitely not want to try to factor. And how did we factor 4 terms previously in the first semester? 4 terms means factor by what? Grouping. However, guess what? No groups. You cannot factor this by grouping. All right, so we're stuck there. Well, let's see. We can use a calculator on the final exam because it's made by the county.
When is that?
I mean, it's made by the county.
When are we taking that?
Let's see. That's going to be like our final exam, right?
No, the,
Oh, the benchmark. That's coming up like 2 weeks from now, I think. I'll give you the heads up. Or maybe, yeah, maybe it's next week. Yeah, I'll tell you when. But anyway, so I have a calculator on the final exam. Can I just type this in? Not really, because it gives you decimal answers, and they're actually not the exact answers, they're only approximate answers. So the TI-84 actually gets it wrong, believe it or not. Not good. So, okay, don't trust those calculators, right? We can do this by hand, and we can do it to perfection. With no calculator, with no factor by grouping, right? Watch the magic unfold. Okay, so the function we have is x cubed plus 6x squared minus x minus 30. And this is actually known as a cubic, is what this is called. Otherwise known as, when you graph it, a what? Snake. Now, a cube gives you a snake. You know what happens if you throw a square into a cube? It's still a snake because of the cube, but if you put an x squared into a cubic equation, it actually makes a snake with a bend. So it's not the standard snake, so the square bends it. Okay?